Very cool. I haven't seen that before. Does everyone know why there's a lighthouse next to the news site? Yeah, some nodding heads. So we'll get to that a little later. So today I want to talk to you about the page load performance of your React applications. So basically, what does it take to get from this screen on the left to this screen on the right? Now, page load and React is not an untrod topic. Sometimes when you hear people talking about this topic, you might get something a little bit more like this, that if you use React, your pages will definitely be slow, and you obviously hate your users. There's kind of this meme that's developed that by using React, you've opted out of the web platform, and you've chosen something that you like to use because it's kind of cool, instead of something that's great for your users. But we all know that React is, of course, just JavaScript, and JavaScript is part of the platform. So today I want to talk about how we can use the general purpose platform APIs and the tools that have been developed over many, many years that the web's been around to help make your React applications faster too. So just as way of an introduction, my name is Josh Duck. I work at a company called Clipchamp. We are based in Brisbane, and we do video editing and encoding tools based in the browser. In the past, I've worked at Facebook, where I managed the JavaScript performance team, and I also helped build Draft.js, and then I left it unmaintained. So I do apologize for that, James. And then until the end of last year, I worked at the ABC, and the ABC is Australia's public broadcaster, and we have a very large web presence, including one of Australia's biggest news websites. And a lot of my job at the ABC was about helping modernize their technology stack, and I want to talk you through what that experience was like from a performance perspective. And this is not just my journey, this is the work of a lot of really talented engineers at the ABC, many of who are here today. We don't have shiny t-shirts, or they don't have shiny t-shirts, but if you kind of look around, you will find them. So I'm going to walk you through metrics, the architectural decisions we made, some of the optimizations we made, and then finally what we actually learned from this as a journey. Now I'm going to start with the architectural bits, because really this is the foundation of your application, so you have to do it at the very beginning. So we used server-side rendering, and then we used prefetching of our data that was delivered via the HTML bundle to boot up our application. Now, this is not particularly novel. Lots of people are doing this now. If you use Next.js, this is what you're getting for free. But this is just one of the kind of approaches that we could have chosen, starting all the way from, well, at the top, client rendering, so just using create React app as is, all the way down to just using server rendering and not running any JavaScript. And this is kind of often held up as the alternative to React. You start with no JavaScript, and then as you kind of have needs, you kind of layer it on. My kind of philosophy on this is that if you start without a plan for actually managing your JavaScript, you're probably going to end up like this. Every site that I've ever seen that's organically accumulated JavaScript throughout the years, you just end up with an unmaintainable and bloated mess. Another option that kind of exists on this spectrum that I'm really excited about is something called progressive hydration. And so this is where you're both server and client rendering, but your application on the client, it can kind of boot up as JavaScript bytes become available. So you're not having to wait to do one big render right at the end of the page. And this is a screen recording that was shared by Dan Abramov that kind of shows how this works in practice. And because of React and suspense, React can do things like queue up all of the events that happened while the page was still loading, and then play them all when the application's ready to handle them, so that you don't lose any of the user interactions, which is an awesome experience. Now, we were using server rendering, like I said, so we had to figure out where we were going to render that markup. So again, there's lots of different options available to us. We didn't use static site generation like you might find with Gatsby, just because of the way ABC works. We're publishing a lot of content very rapidly, and that's invalidating pretty much everything that we've generated up until that point. So we had a pretty traditional Express server, but by using a CDN and heavily caching that content, we were able to get a lot of the same benefits that you might have got with static site generation. And so less than 10% of our page views were actually going back to our Express server. If you don't have that kind of level of caching, you need to make sure that you optimize your server, because if you don't, no amount of client optimizations are going to give you a fast experience. Now, the next decision we made was to use CSS media queries, and I'm not at the wrong conference. It feels a bit strange to be up on stage saying, use CSS media queries. But they solved a really important problem for us, and that was being able to have responsive pages that would quickly adapt to whatever device you were using. And of course, like, it kind of goes without saying, but it's really nice to be able to just take a platform feature that already exists and is very mature and is well documented, and not have to go out and go and download a new library to solve this need for us. So this is our architecture that we put in place fairly early on, and then we started building our applications on top of that architecture. And when we were kind of ready to ship them, we started measuring them in real devices. And they kind of felt like this, right? They were okay. So they weren't great, but they also weren't bad. One measure of success is that we showed them to people and they didn't complain about our sites being slow. And so that's like the minimum bar that you can possibly get to. But of course, there are reasons that you want to get better than this. User experience, conversions, SEO. When I started trying to research more into this, I found out that it's actually quite hard to find data. So the SEO angle was quite surprising to me. Google have publicly said that unless you're the slowest of the slow websites, they actually don't use performance as an input for ranking, which is not in line with what I expected. And then we get the classic Medium post of someone who's rewritten their stack from the ground up. They've redesigned the site and they've kind of seen a bunch of improvements to their business metrics. And this is, it's fantastic that they've done this. It's a great story, and we should feel happy for people who've had this kind of success. But it doesn't really give you data that you can rely on because they haven't controlled any of their variables. Some of the big companies are doing a little bit more to be diligent about collecting this data, but what they'll tend to do is they'll slow down their site so that they can compare the two cohorts of fast experience and slow experience and extrapolate from there. They tend to not want to blog about that because it kind of makes them look bad. What is well established, though, is the science behind how users perceive products. And so the title of this talk is The First 2 Seconds. And that number of 2 seconds, it comes from way back in the 60s when IBM were doing research about how users subconsciously perceived interactions with the user. And they found that when it crossed over that threshold, people perceived that product differently. And so at the ABC, we decided that we wanted to kind of get to this state. We wanted to have a really great performance. And we had done all of that work to get the right architectural pieces in place. That took us a fair amount of time, and it was not wasted effort. But the right architecture or the right technical solutions alone are not going to make your product fast. And that kind of can be a bit hard to hear in an industry where we like to go and find new technical solutions to our problems. It turns out that blazing fast is now what everything is. I did actually remove the Gatsby tag from this slide, sorry, Max. So, just because a library is blazing fast in isolation doesn't mean that you can kind of integrate it into your applications and it, makes your application fast. Real performance is going to come from measuring and then improving and then measuring and improving and measuring and improving and just doing that again and again and again. So, the first step, what do you actually measure? What does it mean for a page to be fast? A great place to start is the Lighthouse tools. So these are built into Chrome. You can find them on the website, web.dev, a bunch of other places too. It gives you a nice shiny score that tells you exactly how fast you are. And that score is actually made by combining a lot of different industry metrics. So here's an example of some, first contentful paint, first meaningful paint, and they're always bringing out new metrics. These are all what are called point-in-time metrics, so that means that you can take them and you can put them on a timeline and you can see exactly when each of those events occurred. There are some other metrics which are a little bit more abstract, like speed index, that tries to tell you how quickly you showed content that was representative of the end state. And we can see this green chart at the bottom. It kind of shows the step-ups because we had content at each of those stages. Because there's more shaded area, we have a higher score and it was a better user experience. Now, the weighting that Lighthouse uses to kind of mix and match all of these metrics is always changing. Here's the breakdown that they're using with Lighthouse 6, which they're going to release sometime this year. And this is basically made up of two main segments. So firstly, how quickly did you show anything to the user? And secondly, did you have any long-running JavaScript that was blocking the main thread? I don't know about you guys, but I happen to be using React. And so this is basically docking as points for using React. That's not as bad as you might think, because just because Lighthouse is the first score you find doesn't mean that that's what you should necessarily optimize for. You instead need to decide what's important for your application. So we used a lot of the metrics that I showed you before, things like first contentful paint. But to augment them, we also developed our own mental model that described the ideal page startup, or at least the sequence that we wanted to have happen. And the ABC sites, they're largely static content and don't actually have a lot of interactivity. And when we ran some performance profiles against our sites, we saw that, yes, there was that big block of React that Lighthouse did not like, but also there was all of this other stuff that was not React. And in fact, that was where a lot of the potential for optimization lay in those segments. So we kind of took this and baked this into our mental model. And we defined 3 phases that we wanted to have happen on every single page. The first was the initial render, where we got all of the content that users might want to see, and we put that on the screen. We made sure that responsive layout was all solved, and nothing was kind of jumping around after this stage. The second was where we made it interactive by having React run. And the third was where we did everything that was kind of non-critical, so things like analytics. Now, having this model really helped us. So often when you're trying to debug or analyze, you might come across something like this. So this is a waterfall diagram that shows a bunch of network requests. And we could kind of zoom in and start going, well, that request might be more important than this other one. But if I just color code these according to those 3 phases, you immediately see where we have exceptions to our ideal behavior. And so that meant that mental model meant we had something that was a lot more actionable than just having a single score and staring at it and going, I want that thing to change. So that gave us what we actually wanted to improve. How did we do that? So we started with phase 1, which is the initial content. So no React in this phase. Number 1 thing was we fixed our cache headers. If you take one thing away from my talk and you haven't done any performance work yet, go and run Lighthouse and then go and fix all the places where your static resources don't have long-lived cache headers and are not gzipped. And that's probably the most impactful thing you can do. And it's also super easy to do. We also introduced font swapping. So this is a really cool technique in CSS that means that the browser can render text using system fonts instead of using custom fonts while those font files are still downloading. And we saved a bunch of time off getting that text on screen, huge wins here. We also started preloading resources. So you can do this with things like HTTP to push, but we used the preload link tags. And this basically tells the browser about what resources we need it to go and fetch. And so here we're preloading our font files. And that means the browser doesn't have to first fetch the CSS file, parse that, discover those font resources, and go and fetch those, which is sequential round trips, which is going to make your page load way, way slower. This is obviously consuming bandwidth though, and so bandwidth is not free. And so we're actually only preloading 3 of our font files, whereas we have 6 all up. We let the browser determine if and when it loads the remaining ones, because they're not needed on every single page. Images were also a huge source of bytes for us. So if you can not load an image, you should not load it. So in our React image component, I think this is the only slide I have with React code on it. I apologize for that. We had a simple intersection observer that just said, when this node scrolls into view, load in the image source. We also had a flag to force that to eagerly load. So for our first phase, anything that was above the fold, we wanted to not wait for JavaScript to execute. The problem we kind of ran into is because we had responsive pages, it wasn't actually possible for a developer to determine what images would be above the fold. And that got really tricky on some complex layouts that we had. And this kind of logic is what JavaScript is really good at doing. But we didn't want to wait for React to kind of boot up to run this code. So instead, we wrote some JavaScript that was not React code, which is a fairly revolutionary concept. And it looked a bit like this, especially after it was minimized. So it was 500 bytes, and it just checked what images were above the fold and preemptively set their image sources. And by doing that, instead of just having that logic in React, but having it in React and also in that bootstrap JavaScript, we saved so much time off getting that first image on the screen. Now, this behavior is coming to browsers, which is really awesome. But like all browser APIs you actually want to use, it's not quite ready yet. So Chrome supports this, Firefox are building support, but Safari have not announced plans. There is a polyfill, but it's essentially just doing what our bootstrap was doing anyway. Now, the second phase was about reducing the amount of time we were running React code. So a really quick win is to use the no module hack, which means that this script tag here will only ever be executed on IE, which is the only browser that needs our polyfills. So a really quick win there. So we saved 22% of time off our first paint by avoiding that JavaScript resource. Now, the Chrome team have also suggested that to kind of take this one step further, You should be building bundles for both modern browsers and IE, and they've said that they've seen between 7 and 22% reduction in JS bytes by doing that. Now, the final technique here is to minimize bytes through bundle splitting, and this is one of my favorite techniques because as your application gets larger, this gets better and better and better. So it's kind of like the opposite of most optimizations you do. And you just replace static imports with dynamic imports that are asynchronous, and that will give your bundler, whether it's Webpack or something else, an opportunity to carve off different packages. And Webpack also have a bunch of tools that help you identify opportunities for doing this. Now, if you're not careful, you can kind of mess this up. So instead of having a big block of JavaScript loading at the start of your page load, you can kind of turn your page load into this. Like you load some JavaScript, you render, you load some more JavaScript, you do some more render. And this is like way, way slower. So to help with this, we used a package called Loadable Components. And this does two really neat things. So firstly, when you're server rendering, it will make sure that dynamic imports are executed. By default, they're not. And so your server render will be missing huge parts of the page. And the second is because it's hooking into Webpack and Babel, it can actually know which dynamic imports were executed. And then it will generate a list of packages you need to preemptively load on the client. So you kind of go from this to being able to load everything up front. And you still have small packages, but you've got nice load behavior too. Now, the final thing we did here was to do some classic React profiling. So the React dev tools have a really great profiler built in. What we found was that it's really, really common for developers to accidentally re-render their components when they're first mounted. So they might be doing things like setting state on component did mount. And that's just wasting time, so just don't do that. React DevTools will help you find those instances. Now, the third phase was things like that were non-critical to the page. And if you've used something like Google Tag Manager, this tweet should be, you should be sympathetic to this. Like at the top, we've got the things that our page actually pulled in. And then beneath that, we've got all of those third-party resources, just like so much JavaScript. For better or worse, this is the way that third-party services want to integrate with your website. And there's not a whole lot you can do about it. There's no checks and balances that force these people to write efficient code. We were in the really fortunate position of not having to run ads on their website because the ABC is taxpayer funded, so thank you very much. But even without ads, we found that 2/3 of the JavaScript that we loaded on any given page was third party. Something like the YouTube Play widget, that was loading in 35% more JavaScript than our React application was, which is absolutely massive. So you can't turn off YouTube, you can't turn off analytics because your marketing people, they first get confused and then they get a bit upset with you. But you can try and minimize the cost. So there's projects like Light YouTube Embed that will defer the cost of loading YouTube until the user actually tries to interact with that video. You can also go through and audit all of your third-party dependencies. So Lighthouse will do this for you, and it tells you how many bytes and how much JavaScript time was spent for every single third-party service that you pulled in. Now, this is just some of the optimizations we made. I definitely don't have time to go through them all. We saw some really good results. So first contentful paint between 30 and 50% faster, around 30% faster for visually complete, JavaScript parse and compile time around 40% faster, and then blocking execution was around 50% faster, so much less time spent blocking the main thread. And numbers are cool, but I think what is better is actually seeing this in practice. So I've got a screen recording of what the site load felt like before and after we'd done this work. So I'm just going to play this now. So you can see there on the right-hand side, way, way, way quicker to get images on the screen, to get layout there. The JavaScript executed much sooner too. So all up, a really good outcome for all of this work. So what did we learn from this process? So firstly, Lighthouse Audit is not a silver bullet. So Lighthouse feels really good when you first run it. It gives you a score that tells you exactly how fast you are. And then it gives you a list of all the things you should improve to make your site faster. It even gives you a number and it's ranked according to how much time you're going to save. When we started doing this, we found that some of these just didn't deliver. Critical CSS was one of the things that we spent a lot of time implementing, and it just gave us absolutely no benefit at all. And then, like I said, Lighthouse is made up of many different metrics. And so some of this work will improve one metric, but regress another. And so your Lighthouse score might go up, but it also might go down. And then when you do that work, Lighthouse helpfully suggests another optimization, which is to literally just undo all of that work that you just did. So you need to take this with a grain of salt. Us having this mental model of how we wanted the page load to work, that was that kind of grain of salt. So we could combine Lighthouse's suggestion with our own understanding and then decide which of these things we actually wanted to do. The next thing is that measuring the impact of changes is hard. Like they say, if you measure something, you can improve it. If you can't measure something effectively, you're going to really struggle to improve it. So I said before that Lighthouse gives you a score that tells you exactly how fast you are. But that's not so true. So this is the same code running on the same hardware, Lighthouse scores over time. And the Lighthouse team are very aware of this, but it's just part of web performance testing is that high variability. And they've said that for any given score, any metric that you look at that touches the network, you should expect plus or minus 15% across runs. And so that means that if you take a Lighthouse snapshot, you make a bunch of optimizations, and then you take another snapshot, no win is going to be larger than 15%, so you actually can't verify that you did anything. So you can't just have that before and after snapshots and compare them. What you can do is take multiple Lighthouse snapshots. So there are tools like PW Metrics that will do this for you. It will run Lighthouse 5 times or 10 times to give you higher confidence. You can also use real user monitoring. So this is where for every person who comes to your site, you will capture some performance data, and then you can kind of aggregate that. And then as long as you have lots of users, you will have lots of data, and you will get higher confidence data. The other awesome thing about this is that you understand the distribution of experiences. So of course, Lighthouse gives you a single score, but everyone is having a different experience when they come to your site. And so this kind of shows you what that full spectrum looks like. The one downside, of course, here is that you have to actually push this code to production. So it complements synthetic testing like you get with Lighthouse. It doesn't replace it. And browsers give you a lot of data to actually build up these data sets and do real user monitoring. So the performance APIs are really cool, and these exist in all of the browsers. And you can do things like say, tell me about every single external resources that was loaded as part of this page load. When was it started? What URL did it fetch? How many bytes did it load? And how many bytes did it load before they were uncompressed? Now, once you get good data, you need to record that. When I was preparing these slides, I hadn't got good data sources, so I ended up checking out our Git repo and old branches and actually rerunning a bunch of stuff that I felt comfortable showing people. What did help here was a tool we had called Calibre that would just record a Lighthouse snapshot at a periodic interval. And so we could kind of say, how much improvement did we have in performance over the last 2 months? You also want to make sure that you are tying this back to specific commits, because you might want to actually relook at performance optimization and revisit that at a later point in time. And it's good to kind of know how good how much improvement you made to performance the first time. And the other reason that I think that this is really important is because performance work is not necessarily like other feature work. So normally when you build a feature, you can show it to people and they can say, yes, I see that you built a feature. With performance work, you can show it to people, then they go, oh yeah, that feels faster, but they can't really see that feeling. And I think that as engineers, we know that it takes a long time to get this right. And so you want to be able to tell a good story. And the numbers kind of help you tell that story and justify that continued investment in this kind of work. Now, the final thing that we kind of learned is that, like I said before, React is part of the platform. So we were able to build a product in React that made use of all of these browser optimizations and all of this general performance tooling. And we hadn't opted out of the platform. And in the end, the cost of React was that big block of JavaScript execution that I told you about. But it took less than 400 milliseconds for most of our users. And that's less time than it takes to actually blink, especially if you blink really slowly. But we were able to sequence things in a way where that didn't block render, and it didn't block any of the important stuff happening. And using React, of course, we've got heaps of benefits. We're all here for the same reason. We love the things you can do with React. But just from a performance perspective, we're able to do things like server rendering, do bundle splitting very easily. And in the future, hopefully, the team can do things like progressive hydration that we just could not have delivered with a less powerful framework. And so thanks to React, we were able to build a page that felt really good. It was the fastest in its class. And the team were really happy with the outcome that we got. So that's the journey we went on. If you have questions, I would love to hear them. Please come and find me in one of the breaks. But thank you very much for listening.